For decades, hypersonic flight has been a classified promise, whispered about in connection with the SR-71 Blackbird, rumored successors, and experimental NASA programs. We've heard the buzzwords Mach 5, plasma sheaths, thermal loads, combined cycle engines. But here's the real question. Why has no one actually built a reusable hypersonic aircraft that flies again and again and again? And what if that's about to change? In this video, we break down how Hermeus and its Quarterhorse program aren't just chasing speed. They're quietly engineering a repeatable, high-cadence hypersonic ecosystem, not a one-off X-plane, not a classified black project, but a scalable system designed to fly weekly, gather data at Mach 5, and transition directly into operational military and civilian platforms. By the end, you'll understand not just how fast Quarterhorse might fly, but why its development model could matter more than the Mach number itself. Let's start at the beginning. Hermeus, founded in 2018 by a team of aerospace veterans from SpaceX, Blue Origin, and Generation Orbit, is on a mission to make hypersonic flight a reality. Backed by heavy hitters like the U.S. Air Force Research Laboratory, the Defense Innovation Unit, and investors including Canaan Partners and RTX Ventures, Hermeus has raised over $100 million to date. Their Atlanta headquarters buzzes with innovation, blending startup agility with defense-grade precision. The Quarterhorse program is the cornerstone of Hermeus's roadmap. It's not a single aircraft, but a family of uncrewed, reusable test vehicles designed to iteratively build toward hypersonic speeds. Their philosophy is rapid prototyping and testing. Design, build, fly, learn, repeat. This approach echoes SpaceX's iterative Starship development, but applied to hypersonics. Quarterhorse aims to achieve Mach 5 by 2026, making it the fastest reusable aircraft ever. Why unmanned? Safety, cost, and the ability to push limits without risking lives. These vehicles are stepping stones to two flagship products: Dark Horse, a military hypersonic drone for reconnaissance and strike, and Halcyon, a commercial passenger jet that could revolutionize global travel. Quarterhorse Mark 0 kicked things off in 2023 as a ground-based test bed. It wasn't meant to fly, but to validate core systems like avionics, software, and remote piloting. Built in just 6 months, Mark 0 underwent rigorous ground tests, including engine runs and taxi trials. This phase de-risked the program, ensuring subsequent versions could focus on flight. Hermeus's CEO A.J. Piplica noted that Mark 0's success proved their high-cadence development model, compressing timelines that traditionally take years into months. Then came Quarterhorse Mark 1, the first to take to the skies. Unveiled in March 2024, Mark 1 was purpose-built for subsonic flight, emphasizing takeoff, landing, and low-speed handling. Powered by a General Electric J8521 turbojet, the same engine used in the T-38 Talon trainer, Mark 1 featured a sleek delta-wing design optimized for stability. Its first flight occurred on May 21, 2025, at Edwards Air Force Base in California. The remotely piloted hop was short but monumental. It validated control surfaces, high angle of attack performance, and flight software under real conditions. Ground testing prior to flight was completed in just 21 days, including 130-knot taxi tests. This rapid pace, from design start in fourth quarter of 2023 to flight in under 19 months, set a modern record for jet aircraft development, surpassing even the post-World War II era's urgency. Data from Mark 1's flight informed immediate iterations. Hermeus reviewed telemetry on aerodynamics, propulsion integration, and remote operations, feeding lessons into Mark 2. The test highlighted the effectiveness of their custom flight deck, a ground control station that allows pilots to operate the vehicle like a simulator turned reality. This milestone didn't just prove the airframe, it unlocked funding and partnerships, solidifying Quarterhorse's role in DoD hypersonic initiatives. Now move to Quarterhorse Mark II. Assembly began in mid-2025 at Hermeus's Atlanta facility, with key milestones stacking up quickly. In September 2025, the Pratt & Whitney F-100 turbofan engine, the powerhouse behind the F-15 and F-16 fighters, was integrated into the airframe. This engine delivers over 29,000 pounds of thrust with afterburner, enabling supersonic dashes. But Hermeus isn't using it off the shelf. They've incorporated a proprietary pre-cooler system that chills incoming air to prevent compressor stalls at high speeds, a critical enabler for the hypersonic transition. By November 2025, the tail and wings were attached, completing the major structural assembly. Mark II features a delta wing configuration roughly the size of an F-16, optimized for supersonic stability and low drag. In January 2026, the refined Mk 2.1 variant was shipped to Spaceport America in New Mexico, a shift from Edwards dry lake beds to a dedicated high-speed test site known for its vast airspace and isolation, perfect for pushing boundaries without interference. Hermeus established a full hangar and operations there, deploying their team to support the campaign. The ground test phase has been intense and rapid. Upcoming steps initially included reintegrating the tail and wings, if needed after shipment, system checks, engine ground runs, and progressive taxi testing. But Hermeus has moved fast. On February 13, 2026, they released a tweet showcasing Mark 2.1 coming alive on the runway. The video accompanying the post reveals a montage of key milestones, full thrust firings of the F-100 engine, with massive exhaust plumes kicking up dust clouds in the New Mexico desert, multiple drop tests where the aircraft is lifted and released to simulate landing stresses and validate landing gear, ground vibration testing, shaking the airframe to identify resonance frequencies and ensure structural integrity, and verification of vehicle ground systems, including avionics integration with the control station. As of now, low-speed taxi testing is underway, validating ground handling and systems ahead of takeoff. Hermeus aims for first flight in early 2026, potentially within weeks, making Mark II the world's first supersonic uncrewed aircraft developed in this rapid cadence. This phase will validate supersonic regimes up to Mach 3 to 4, collecting data on shockwave management, thermal loads, and control authority. Success here paves the way for hypersonic leaps, and with the U.S. Air Force watching closely, Mark II could support early DoD test events by mid-2026. Building on Mark II's momentum, Quarterhorse Mark III represents the hypersonic heart of the program. Slated to roll out in late 2026, Mark III will be the first to integrate the full Chimera engine, Hermeus turbine-based combined cycle power plant. Chimera operates in dual modes, as a turbojet for subsonic and supersonic speeds up to Mach 3 to 4, then transitioning to ramjet for hypersonic flight beyond Mach 4. This seamless switch is enabled by variable geometry inlets and the pre-cooler tech debuted in Mark II's F-100 mods. Ground tests of Chimera in 2023 already demonstrated full mode transition, a world first for a commercial engine. Mark III's design will incorporate lessons from prior variants, featuring advanced materials like carbon-carbon composites and ceramic matrix composites to withstand the extreme heat of hypersonic flight, where skin temperatures can exceed 3,000 degrees Fahrenheit. The airframe will be larger and more robust, optimized for sustained Mach 5 dashes. Flight tests are expected to begin in 2027, focusing on hypersonic stability, thermal management, and engine performance in real atmospheric conditions. Hermeus plans for Mark III to achieve speeds over Mach 4 initially, scaling to Mach 5 with iterative flights. This vehicle will be reusable, capable of multiple missions per week, thanks to rapid turnaround designs inspired by SpaceX. With the Quarterhorse family maturing, Hermeus' future projects, Dark Horse and Halcyon, promise to translate these tests into game-changing platforms with profound implications. Dark Horse is a multi-mission, reusable, hypersonic unmanned aerial system designed for defense and national security. Building directly on Quarterhorse tech, Dark Horse could feature twin Chimera 2 engines for enhanced payload and range, pushing speeds above Mach 5. Roughly the size of a fighter jet, it would carry sensors, weapons, or electronic warfare suites, enabling rapid reconnaissance over contested areas or precision strikes that outpace enemy defenses. Dark Horse's development is tied to U.S. Air Force contracts, with prototypes expected by 2028 to 2030. It addresses critical gaps in U.S. hypersonics, where adversaries like China with the DF-17 and Russia's Kinzhal have fielded operational systems. The implications are staggering. Dark Horse could penetrate anti-access/area denial bubbles, delivering time-sensitive intelligence or hypersonic munitions in minutes rather than hours. In a Pacific conflict, it might surveil the South China Sea from California in under an hour, striking mobile targets before they relocate or providing real-time data to carrier groups. This shifts warfare paradigms from predictable satellite orbits to unpredictable high-speed drones that evade radar and missiles, reducing casualties and escalating deterrence. By integrating with networks like JADC2, Dark Horse enables seamless, AI-orchestrated operations across air, sea, space, and cyber domains, potentially preventing wars through overwhelming superiority. On the civilian side, Halcyon is Hermeus' bold vision for commercial hypersonic travel, with equally transformative effects. Aimed at carrying 20 passengers at Mach 5 over 4,000 miles, Halcyon could slash transatlantic flights to 90 minutes. Development draws from Quarterhorse's aerodynamics and propulsion, with a larger fuselage for cabins and fuel. First flights are projected for the 2030s, pending certification. Challenges include mitigating sonic booms via quiet boom tech, using sustainable aviation fuels, and ensuring passenger safety amid G-forces and heat. Hermeus isn't just building planes, they're expanding infrastructure to amplify these impacts. In 2025, they broke ground on the Hypersonic Engine and Airframe Test (HEAT) facility in Atlanta, set for weekly hypersonic tests starting in 2026. This addresses U.S. testing shortages, accelerating the ecosystem and enabling faster iterations for Dark Horse and Halcyon. In the end, the Quarterhorse is kicking off a hypersonic boom with massive ripple effects. From Mark Zero's taxi tests to Dark Horse shaking up defense tactics and Halcyon making the planet feel smaller, these jets are rewriting the rules of flight. With more tests on the way, Hermeus is cranking up the pace, pulling us all into a faster, bolder tomorrow.